Today we're going to be talking about equations with brackets. Equations that contain brackets can be solved very easily using three steps. Firstly, expanding the brackets out using the distributive law. Secondly, collecting the like terms that might be expanded out. And also then just completing the solve and complete solving the equation using normal algebraic methods. First, we've got some examples here. First example, 3p plus 4 equals 18. So firstly, a first step is to expand it out using the distributive law, expanding out the brackets here. So 3 times p plus 3 times 4. 3 times p plus 3 times 4 equals 18. So here we can do 3 times p is 3p, 3 times 4 is 12. So we don't have any like terms here, so we cannot collect any like terms, so we can go straight to the last step, which is then just solving this algebraically. So we can take 12 from both sides, getting 3p equals 6, 18 minus 12 is 6, and this plus 12 minus 12 is going to be 0, so we're left with 3p. 3p equals 6. So we can divide both sides there by 3. 3p divided by 3 is p, 6 divided by 3 is 2. So here, our next example, we've got, we can double check this, by substituting it back in. P equals 2, we can substitute this back in to our original equation to see if these equations are equivalent. So p equals 2, so we can say 2 plus 4 is 6, 6 times 3 is 18. So these equations indeed are equivalent. So here we go, for the second example, negative 12 times 3q plus 5 equals negative 132. We can expand this out using the distributive law. Negative 12 times 3q plus negative 12 times 5. So we've got negative 12 times 3q plus negative 12 times 5. Negative 12 times 3q is negative 36q, because negative 12 times 3 is negative 36, and negative 12 times 5 is negative 60. Equals negative 132. So we've just expanded the brackets out there. We can simplify this plus minus to just a minus, because if we add a negative, it's the same as subtracting the number away. So we've got negative 36q minus 60 equals negative 132. Now we don't have any like terms, so we can't collect any of the like terms, so we can just go to the last step and solve this problem algebraically. So here we can add 60 to both sides. Adding 60 to both sides will remove this minus 60 here, and we'll just be left with minus 36q. Adding 60 to this side, to negative 132, will be negative 72. So negative 132 plus 60 is negative 72. We can then, if we divide negative 36q by negative 36, we will get just q. So we can do that to both sides, divide by negative 36. So negative 72 divided by negative 36 is 2. Q equals 2. Third problem, 4 times 2x minus 5 plus 3x equals 57. Firstly, we need to expand those brackets out. That's our first step. So 4 times 2x minus, because we've got a minus sign here, 4 times 5. So 4 times 2x minus 4 times 5 plus our 3x equals 57. Notice we haven't included the plus 37 in this part, in our expansion, because it's not part of the brackets. It's an additional term added to the end. So here, 4 times 2x minus 4 times 5. So we can multiply those two together. 4 times 2x is 8x. And 4 times 5 is 20, minus 20. So now we do have some like terms here. We've got our 8x plus 3x. They're like terms. They both have x in them. So 8x plus 3x is 11x. And we've still, the minus sign, the subtraction, is still out the front of the 20. Minus 20 equals 57. Now we don't have any more like terms. So all we can do now is finally solve our equation algebraically. So we can add 20 to both sides to get rid of this subtract 20. So adding 20 to both sides, we'll get 11x on this side. 57 plus 20 is 77. So then we've got 11x equals 77. We can divide 11x by 11 to get just x. and 77 divided by 11 is 7. So we've got x equals 7. Our last problem here, our last example, 2 times 3k plus 1 equals 5 times 2k minus 6. So we've got two sets of brackets here, but we can solve them both at the same, or we can expand them both, expand them using the distributive law at the same time. So 2 times 3k plus 2 times 1, 2 times 3k plus 2 times 1, and here 5 times 2k minus 5 times 6. 5 times 2k minus 5 times 6. So 2 times 3k is just 6k, 2 times 1 is 2, 5 times 2k is 10k, minus 5 times 6, which is minus 30. So here we've got an equation. We don't have any like terms on either side. There's no like terms on this side, no like terms on this side. So we can solve this problem as we would normally. So here we've got a variable on both sides of the equation, so we can subtract one of those variables away. So we'll take away 10k, and this side will then have 10k minus 10k, which is 0. So we'll just be left with our minus 30. We need to do the same to this side as well though. 6k, take away 10k, is going to be negative 4k, minus 4k. So here we've got our 6k has become minus 4k. Nothing's happened to our 2 because this is not a like term to the 2's. It has no effect on them. Minus 30 is just minus 30 as well, and we've gotten rid of our 10k. So now we can solve this normally. Take 2 from both sides to remove this 2, and that will get minus 4k equals negative 32, because negative 30 minus 2 is negative 32. Here we've got negative 4k equals negative 32, so if we divide negative 4k by negative 4, we'll get just k. We need to do the same thing to both sides though. So negative 32 divided by negative 4 is positive 8, because a negative divided by a negative is a positive. K equals 8.